Okay, so continuing on where we left off with the ambiguous case for the sine law. In this question then, we're asked to solve this triangle. So we would have a look at this and say, well, we know the measure of angle A and its corresponding side, so we're definitely going to use that information. And since it's side B that's given, let's start there and use the sine law to find the measure of angle B. So if we're trying to find the measure of angle B, we'll set this up as sine B over B equals sine A over A. And we'll fill in the information we know. So sine B over 7.8 equals sine 36 degrees over 5.9. From there, we'll multiply by 7.8 on both sides. Okay, and as a decimal there on the right-hand side, we get 0.7771. Typing into our calculator, the sine inverse of 0.7771 tells us that one possible measure for angle B is 51 degrees. Okay, so if angle B is 51 degrees, then we could say angle C is going to be 180 degrees minus 51 degrees minus 36 degrees, so 93 degrees. And then all we would have left to do is find the length of side C. And to do that, we could use the sine law. So we could say, let's separate this with some numbers so we're clear. This was step 1. Then we found angle C. Okay, and here as step 3, we're going to find side C. So we know that C over sine 93 is equal to 5.9, using side A again, over sine 36, multiplied by sine 93 on both sides. Okay, and we get that C is approximately 10 centimeters. Okay, so that's one solution for this triangle, namely the first triangle we drew, right? That would be our solution to this first version of the triangle where all of the angles are acute. Now where the other solution comes in, okay, is right here at this step. Because if you remember from when we were solving trigonometric equations, that equation has two solutions for angle B. Actually, it has more than two solutions for angle B, but since we're dealing with angles in a triangle, of course, they're not going to be greater than 180 degrees. So in the first two quadrants, though, this equation has two solutions. So let's bring this over here. Okay, and I'll do the second solution in red just so you can keep them separate. So we could say in quadrant 2 then, okay, the corresponding angle to 51 degrees, which was, oh, let me fix that, which was our first solution we found. So remember solving questions like this before, we'd have to say sine is also positive in quadrant 2. Okay, so the corresponding angle in quadrant 2 we could find by subtracting, so we'll say this is our measure for B2. Okay, we could find by subtracting 51 degrees from 180. So it's also possible that angle B is equal to 129 degrees. And if you look up at the second version of the triangle we drew, that makes sense. because this is clearly an obtuse angle. Okay, so now we've found that possibility, that possible angle. Now, if that angle was 129 degrees, then C, okay, in this triangle would be 180 degrees minus 129 degrees minus 36 degrees. So in that second triangle, C would be 15 degrees. Okay, so now we've got B is 129 degrees, C is 15 degrees. And in that case, we could find the measure of side C the same way we did in the first solution, but we have to fix the, or change the angle C to 15 degrees. Okay, but otherwise, this step of the solution is going to be the same. So the process stays the same, but of course all these values change because we used a different angle for B. We found a different value for angle B. So multiply both sides by sine 15 in this case. Okay, and so in this triangle, side C would be 2.6 centimeters. So now you've got two completely different solutions, both of which are correct. Okay, so you've got two solutions, one on the left, one on the right, both which satisfy the criteria that was given in this question. Now, in order to identify questions that do involve this ambiguous case, there are some criteria you can look at. Okay, so when you are given angle A, its corresponding side, and another side, which, by the way, the triangle obviously doesn't have to be labeled ABC, okay? But what this is saying is if you are given an angle, the corresponding side, and one of the other sides, no matter what they're labeled as, there are three possibilities, okay? What we do first is we calculate B sine A, as in B times sine A. Then compare that result to the length of side A. If side A is less than that result, then there's no triangle possible. You can't draw that triangle at all. If A equals B sine A, there's one triangle possible, and that would be a right triangle. But it's when A is greater than B sine A that there would be two triangles possible. Okay, so those criteria you can check when you're given a question and you have to draw the triangle yourself. You could quickly check the value of B sine A, compare it to the other side that's given, and then you'll know how many solutions it is that you're looking for. So we'll go through another example here. And in this case, we'll use the criteria that I just gave you to first determine how many solutions we would be looking for. So it says determine the number of solutions and then determine the length of the third side. So in this first one, okay, we're given angle A, side A, and a third side, which is side C. So this is kind of what I meant about the fact that it doesn't always have to be labeled ABC. Okay, in this case, the third side is C. So we're going to check the value of C sine A. So C is 5 and A is 30 degrees. So that equals 2.5. Now A is 3. So in this particular case, A is greater than C sine A, which tells us right away that there are two solutions. Okay, so in other words, we're going to have two solutions for the length of the third side. So let's go ahead and set up the sine law to find, first of all, the length of side C. All right, so sine 30 over 3, sine A over A, would be the same as sine C over 5. Multiply by 5 on both sides, to get sine C by itself as a decimal. That is 0.8333, which means that angle C is sine inverse 0.8333, which gives us 56 degrees. That's one possible solution. Okay. So if angle C is 56 degrees, then we could find angle B, this will be our second step, by subtracting the angles we know from 180 degrees. So subtract 30, subtract 56, which means that one possibility for angle B is that it's 94 degrees. Okay, now I wasn't asked to find the measure of angle B, but I needed to, okay, because I was asked to find the length of side B. And in order to use the sine law to do that, I need to know the length of, the measure of angle B. Okay, so now let's go ahead and use the sine law then to find, sorry, I'm messing this up a little bit. Let's go ahead and use the sine law to find the measure of side B. Okay, so our third step will be to use the sine law. So we'll have B over sine 94 degrees on one side, and we'll use A and sine A on the other. So 3 over sine 30. Multiply both sides by sine 94. So the length of side B would be approximately 6 centimeters. Okay, so therefore one possible length for side B is 6 centimeters. However, that's not the only length possible. Okay? So, another possible solution is going to be to go back to this stage here and say that there would also be a corresponding solution in quadrant 2. So in quadrant 2, a second value for angle C would be 180 degrees minus 56 degrees. So a second possibility is that angle C is 124 degrees. If that's the case, then angle B would be 180 minus 124 minus 30, which is 26 degrees. Okay, so in this obtuse triangle then, if angle B is 26 degrees, then we're going to redo the sine law, but this time it'll be B over sine 26 degrees equals 3 over sine 30. Okay, and I'm running out of time on this video. You're going to multiply both sides by sine 26. And we're going to see that the other answer possible for the length of side B is 2.6 centimeters. And at this point, I'm going to need you to switch to video 5 part 3.